Hi guys, welcome back to our notes 7.1, finding the area between two curves. Now in example 2, we have two functions of y. We want to sketch the region bounded by the curves and find the area. So first, I'm going to algebraically solve for where these two functions intersect. So they intersect when they are equal to each other. So I have 2y minus y squared equals negative y. I'll add y to this side. Negative y squared plus 3y equals 0. Factor out a negative y. And that leaves y minus 3 equals 0. So y equals 0 or y equals 3. So first, I solved algebraically to see where my functions intersect. Now what I'm going to do is set up a table for each of these. So remember, for my first function, x equals y times 2 minus y. And my y values are going to go from 0, 1, 2, 3. Those are my y values between here. Then for my second table, x equals negative y, and once again my y values go between 0 and 3. So this one's pretty easy. 0, negative 1, negative 2, negative 3. This one, let's see, this is going to be 0. If I plug in 1, 1 multiplied by 1 is 1. If I plug in 2, 2 multiplied by 0 is 0. If I plug in 3, 3 multiplied by negative 1 is negative 3. So we see they do intersect at these points. So now I'm going to draw this graph. And I usually only do these tables and such when there's functions of y because it's just easier for me to see what's happening. So now let me graph this. First one is at 0, 0, 1, 1, 0, 0, 2, and then negative 3, 3. So there's my first function. And I'll go ahead and do the other one in a different color. 0, 0, negative 1, 1, negative 2, 2, negative 3, 3. So there's my second function. So we're looking for this area here. So they're already functions of y, and I could see it's easier instead of drawing a vertical Riemann sum, because if I did, I'd have to switch up and it wouldn't work here because I'd have a function minus itself. It's easier to draw a horizontal Riemann sum rectangle, and the base of that is dy. Now remember, whenever we're looking for the height of a horizontal Riemann sum, it's right minus left. So area equals the integral from 0 to 3 of right minus left. Y times 2 minus y minus negative y dy. So now I need to solve this integral to find the total area. So area equals the integral from 0 to 3 2y minus y squared plus y dy. Area equals the integral from 0 to 3 of 3y minus y squared dy. So that area equals 3y squared over 2 minus y cubed over 3 from 0 to 3. Which becomes, what's this, 27 over 2 minus 27 over 3. If I multiply common denominators times 2 times 2 times 3 times 3, we've got 81 over 6 minus 54 over 6, which is 27 over 6 which reduces to be 9 over 2 units squared for area. So let's try some more examples.